Children, I am going to teach you Neet 2000, Neet 24 few problems. Few problems I am going to discuss with you. Few problems. Lecture 1. Okay. Now, suppose if A cross B equal to A dot root 3 A dot B, then what is the value? What is the value of theta in between A vector and B vector? Now A cross B mod, magnitude of A cross B, root 3 A dot B. Question is, what is the angle in between A vector and B vector? Now from 1 we have A cross B mod means A B sin theta. You know that A cross B means A B sin theta. Again we have A dot B means A B cos theta. So we have what can we write? We write A B sin theta equal to root 3 AB cos theta. That means tan theta equal to root 3 or theta equal to 60 degree. So it is proved that angle between A and B is 60 degree. Okay. Thank you. Again I am telling you A cross B equal to root 3 A dot B. Very simple. A cross B equal to AB sin theta. A dot B means AB cos theta. Basically we know. Then putting these two values in one, we have AB sin theta root 3 AB cos theta. So tan theta equal to root 3, theta equal to 60 degree. So you can write angle in between A and B 60 degree. Now another problem on projectile motion. Another problem on projectile motion. What is the problem? Problem 2. Projectile motion. Projectile motion. Where it is given maximum height equal to total range of the projectile. The question is what is the angle of projection? What is the angle of projection? Angle of projection. Now according to this problem projectile motion, basic fundamental equation I am going to derive. Not derive, I am using maximum height. You know, if you throw a particle making angle theta with horizontal direction, then maximum height h. Now h equal to u square sin square theta by 2g. Equation number 1. Maximum height for this projectile equal to h equal to u square sin square theta by 2g. range, the maximum height, now range r equal to 2u sin theta by g u cos theta. That means time of flight into horizontal component of this velocity. Now we have u square sin square theta by 2g equal to 2u square sin theta cos theta by g. Cancel g and g, u square and u square you cancel, we obtain tan theta equal to 4 or theta equal to tan inverse 4. That means this is the angle by which the particle should be projected so that maximum height equal to range of the projectile. Thank you. Next. So one by one from different chapters I am going to discuss with you. Those are appearing for Neet 2024, which will be held most probably in May. Next problem you follow. I am giving you this problem. Suppose this problem from motion. This is the problem from motion. What is the problem? From motion, what is the problem? Suppose displacement x equal to 2t minus 2t square, and along y direction displacement is 10t. It is clear that displacement is a x, that is function of time, and y is a function of time. So if you take 2 times derivative of x with respect to time, we are getting acceleration along the direction of x. So we have at t equal to 2 second acceleration, displacement given, y given, at 2 will calculate acceleration. So to calculate acceleration, let us consider y equal to 10t, or taking dy by dt, that is equal to 10. That means velocity along y direction constant. So acceleration ay will be 0 along direction of y direction, no acceleration. Again, if you consider dx by dt, that means 2 minus 4t. Again you are getting vx. Again dvx by dt equal to 0 minus 4, that is minus 4. That means acceleration, that is always a negative acceleration, along x direction ax equal to minus 4. That means it is retardation. Negative acceleration means retardation. Again I am telling displacement along the x 2t minus 2t square, y 10t, at t equal to 2 second, calculate the acceleration. First dy by dt is clear, the 10 means no function of time, velocity not changing, constant along the y direction, velocity constant. So ay equal to 0, but vx dx by dt 2 minus 4t. Again you take the derivative dvx by dt, you are getting 0 minus 4, then minus 4, ax equal to minus 4. That means along x direction we are getting negative acceleration or retardation. Thank you. Next. Next, if I want to calculate, suppose a body moving 100 kilometer, 100 kilometer, a body moving A to B 100 kilometer, body 50 kilometer. You divide these two parts into two parts, that is AC 50 kilometer and BC also 50 kilometer. Now body moves AC with velocity, suppose imagine velocity it is 10 kilometer per hour, and for BC velocity is 25 kilometer per hour. Then what is the average velocity? Again I am telling you the problem. Problem number, that is average, problem on average velocity. Average velocity, problem on average velocity. Now A and B, total path 100. You are dividing the path into two equal parts, 50-50. First 50 kilometer it moves with velocity 10 kilometer per hour. Next 50 kilometer it moves with velocity 25 kilometer per hour. Now total time for journey, first 50 kilometer you are getting time T1 equal to 50 by 10, that means 5 hour. Next journey T2 50 by 25, that is 3 hours. Now average velocity equal to total path 100 by total time 8. Total path 100 by total time 8. So we have 12.5 kilometer per hour. So it is clear that particle moving with average velocity 12.5 kilometer per hour. Next problem, last problem for your practice. What is the dimension of, calculate dimension problem, dimension of epsilon naught. Now dimension of epsilon naught to determine, first to consider Coulomb force F equal to 1 by 4 pi epsilon naught charge square by distance square. In this formula epsilon naught we have equal to q square f r square. Now dimension of q equal to, you know, I equal to q by t, so q square equal to I square t square. So if you put, then we have I square t square by force, dimension of force ml t to the power minus 2, r square means l square. So we have I square t square l to the power minus 3 and t square again m to the power minus 1. So it is coming I square t4 l to the power minus 3 m to the power minus 1. So we are getting dimension of epsilon naught. Next, another problem I am going to discuss with you, that is, suppose x equal to at plus bt square. X equal to, problem number 2, x equal to at plus bt, dimension of x equal to distance. Calculate dimension of A and B. Left hand side dimension distance. Each term on right hand side dimension will be distance. So dimension of AT equal to, AT equal to L, the dimension of A equal to L t to the power minus 1. Similarly, dimension of bt square equal to L, dimension of b equal to L t to the power minus 2. That means you are getting dimension of x equation. Now each term of right hand side separately equal to dimension of left hand side, that is displacement. So AT dimension equal to displacement dimension, and bt square again for displacement dimension. So we are getting A and B dimension of AB. Thank you all. Next class, wait for practice.